Hello everybody, welcome to my channel. This is the first video of my channel and also the first video of basic electronics series. In this video we are going to talk about resistors. We're gonna have some basic concepts like their usage, units, symbols, types, materials, how to read their values, and also some intermediate and advanced level topics like considerations to choose a resistor, coding systems, standard values, SMD resistors coding schemes, and some exceptions in codings. I hope you find it useful, so let's go to video. Resistor is one of the most widely used components in electronic circuits. There are many different types of resistors available, having different properties and used in different ways in different circuits. So what is a resistor? In its simplest form, the resistor is an electrical component that restricts the flow of electrons. A resistor, from the point of view of math, is the simplest implementation of Ohm's law. I think all of you are familiar with Ohm's law, or you heard about it before. The law says the current flowing through a material is directly proportional to voltage applied across that material. In other words, V is equal to R times I, which is the classic formula we are all familiar with, where V is the voltage in volts, I is the current in amps, and R is the resistance. There are two main circuit symbols used for resistors. A resistor is often depicted as a two-terminal device with either a jagged symbol or a rectangular symbol. The jagged symbol is widely used in North America, and the other symbol is more widely used in Europe and Asia. The electrical resistance of a resistor is measured in ohms. The symbol for an ohm is the Greek capital omega. The definition of 1 ohm is the resistance between 2 points where 1 volt of applied potential energy will push 1 ampere of current. Since the ohm is a rather small quantity circuit-wise, resistors are measured in hundreds of ohms, thousands of ohms or kilo, or millions of ohms or megohms, and also in some cases in milliohms, that is equal to 0.001 ohm. Resistors exist in just about every electronic circuit. Here are some examples of their usage. They can be used as complement to active components like op-amp, and as you can see here, it can be used as feedback for op-amps. For example, in here it's used as negative feedback, or also it can be used for filtering input signal to op-amps. As you can see here, this resistor along with this capacitor made a high pass filter that can filter input signal before going to this op-amp. It also can be used for current limiting purposes. A current limiting resistor is exactly what its name describes. Anytime you need to limit the current going to another component, you can do so by inserting a resistor in series with that component. As you can see in this picture, it's used as a current limiter for this LED. An LED will have a certain forward voltage called VF. That is the voltage which is required to make an LED light up. And it varies between 1.7 volts and 3.4 volts, depending upon the color of the LED. And also a specific current that it requires to be turned on and giving off the light. That is called IF. The maximum forward current is usually around 20 milliamp for basic LEDs. Continuous current through LED should always be equal to or less than that current. Once you have got those two values, you can size up this resistor with this equation. R is equal to Vs minus Vf divided by IF. A voltage divider is a resistor circuit which turns large voltage into a smaller one using just two resistors in series like this. Output voltage can be calculated by this formula. V out is equal to R2 divided by R1 plus R2 times V in. Another usage is pull up or pull down resistor. A pull up or pull down resistors are normally used in digital circuits to define the default status of the pin. Consider a microcontroller input pin, for example. When there is no voltage applied to circuit that is connected to this pin, you can read either 1 or 0 in this pin, and there is no guarantee that you will read 1 or you will read 0 if there is no pull up or pull down resistor. This situation is called as floating pin. To avoid this situation, the pin is usually pulled up by connecting a resistor to VCC or pulled down by connecting a resistor to ground. The value of resistor will be normally 10 kilo or 4.7 kilo. Pull down resistors are less common than pull ups, but can still be useful, especially if you are dealing with a need for defaults to be low or ground. Pull-ups resistors are often used when interfacing with a button or switch input. The pull-up resistor can bias the input pin when the switch is open, and it will protect the circuit from a short when the switch is closed. Another usage is current shunt. These are low-value resistors that are used to measure currents without interfering much with the circuit under test. They have low resistor value and high power rating. In this method, the current to be measured is allowed to pass through the resistor, and the voltage drop across the resistor is measured. Once we know the voltage drop and the resistor value, we can use the Ohm's law that says that I is equal to V divided by R to calculate the value of the current. In some cases, they are used as series termination resistors. These resistors are recommended only in the case of very high frequency communication or when the communication line traces are over a large trace distance. You usually see them in high-speed microcontroller or microprocessor circuits with high frequency signals. For example, in this circuit, R8 and R9 resistors on D plus and D minus pins are series termination resistors. Or you may be seeing them in long distance communication systems like RS485 and CAN protocols. The purpose of using this resistor is to prevent reflection of signals. Reflection can cause problems on our original signal. They are advanced topics and I will cover them in future videos. Thank you for watching this video. Please subscribe to my channel and like the video if it was useful for you. I will see you in next video.